Welcome to Math Zone African Motives. In this tutorial, we will be diving into Module 4. Today's video will walk you through the process of factoring a cubic polynomial. Our main goal is to understand how to break down a cubic expression into its simpler linear factors. By the end of this tutorial, you will be able to factorize any cubic polynomial into its three linear factors. Let's begin by defining the general form of a cubic function. The general equation for a cubic function is y equals x cubed plus bx squared plus cx plus d. Here, a, b, c, and d are constants, and a cannot be zero, otherwise it wouldn't be a cubic. An important concept for cubic functions is finding their intercepts. The y-intercept is easy to find. The y-intercept occurs where the graph crosses the y-axis, which is when x equals 0. If you substitute x equals 0 into our cubic function, you get y equals d. So the y-intercept is at the point 0, d. This gives us 1 point on our graph. Finding the x-intercepts is more complex. These are the points where the graph crosses the x-axis, which means y equals 0. This leads us to the equation. X cubed plus bx squared plus cx plus d equals 0. Solving this equation is how we find the x-intercepts. A cubic equation can have 3, 2, or even just one real root, which correspond to the number of x-intercepts. To solve this equation, we use a very important tool. That tool is the factor theorem. Although not strictly part of the N4 syllabus, it's a foundational concept you learned in previous levels, and it's essential for what we're about to do. So let's quickly review it. The factor theorem provides a direct link between the roots of a polynomial and its linear factors. It's a quick test we can perform. The theorem states that if we have a polynomial function, which we can call f of x, and we find that f of p equals 0 for some number p, then x minus p is a factor of that polynomial. In other words, if p is a root of the equation, then x minus p is a factor. Once we use this theorem to find our first linear factor, we're not done. We still have a cubic and only one factor. So what's next? To find the remaining factors, we use a method you've seen before. Polynomial long division. We will divide our original cubic polynomial by the linear factor we just found. This division will result in a quadratic expression, which we can then factor using methods we already know, like the splitting the middle term method. To summarize, the strategy is this. First, use the factor theorem to find one factor. Second, use long division to reduce the problem to a quadratic. Third, factor the resulting quadratic to get the last two factors. Now, let's put this theory into practice. We'll work through an example exactly as it appears in your textbook. The question asks us to factorize the polynomial x cubed minus 2x squared minus 5x plus 6. The first step, according to our strategy, is to use the factor theorem. We need to find a value for x that makes the polynomial equal to 0. Let's call our polynomial f of x. The factor theorem tells us to try integer values that are factors of the constant term. In this case, our constant term is 6, so we can try plus or minus 1, 2, 3, or 6. These are our candidates for roots. The example suggests we try x equals 1. Let's test x equals 1. We substitute 1 into our function. That's 1 cubed minus 2 times 1 squared minus 5 times 1 plus 6. This simplifies to 1 minus 2 minus 5 plus 6, which equals 7 minus 7, or 0. Since f of 1 equals 0, we have found a root. The factor theorem confirms that x minus 1 is a factor of our polynomial. This is our divisor for the next step. Now that we have our first factor, x minus 1, our goal is to find what's left over when we divide our original cubic polynomial by it. To do this, we use polynomial long division. We set up our long division like this. The dividend is our cubic x cubed minus 2x squared minus 5x plus 6, and our divisor is x minus 1. We focus on the leading terms. What do we need to multiply x by to get x cubed? The answer is x squared. We write x squared on top. Now we multiply this x squared by the entire divisor, x minus 1. This gives us x cubed minus x squared, which we write below. The next step is crucial. We subtract this result from the part of the polynomial above it. Remember to distribute the negative sign to both terms. X cubed minus x cubed is 0. Negative 2x squared minus negative x squared is negative 2x squared plus x squared, which equals negative x squared. Then we bring down the next term, negative 5x. Now we repeat the process with our new leading term. What do we multiply x by to get negative x squared? We need to multiply by negative x. We write negative x on top. We multiply negative x by x minus 1 to get negative x squared plus x, and we write that below. Again, we subtract the entire line. Negative x squared minus negative x squared is 0. Negative 5x minus x is negative 6x. And we bring down the last term, plus 6. One last time. What do we multiply x by to get negative 6x? We multiply by negative 6. We write negative 6 on top. Negative 6 times x minus 1 is negative 6x plus 6. We write this below and subtract. Negative 6x minus negative 6x is 0. 6 minus 6 is also 0. Our remainder is 0. This is a great sign. It confirms that x minus 1 is indeed a perfect factor. So we've successfully divided the cubic. This means we can now write the cubic as a product of its factors. Our original polynomial x cubed minus 2x squared minus 5x plus 6 is equal to the divisor x minus 1 multiplied by the quotient we just found, x squared minus x minus 6. We're in the home stretch now. We have two factors, x minus 1 and the quadratic x squared minus x minus 6. The first factor is a linear factor and cannot be broken down further. The second factor, however, is a quadratic and can almost always be factorized into two more linear factors. Our task is now to factor the quadratic expression x squared minus x minus 6. To do this, we need to find two numbers that multiply to the constant term negative 6 and add up to the coefficient of the middle term, which is negative 1. So we're looking for a pair of numbers with a product of negative 6 and a sum of negative 1. Let's list the factors of negative 6. Negative 3 and 2, negative 2 and 3, negative 6 and 1, or negative 1 and 6. Which pair adds up to negative 1? Negative 3 plus 2 equals negative 1. This is the pair we need. This means we can factor the quadratic as x plus the first number, 2 times x plus the second number, negative 3. This simplifies to x plus 2 times x minus 3. Now we can substitute this back into our complete factorization. So x cubed minus 2x squared minus 5x plus 6 is equal to our first factor, x minus 1, multiplied by the two factors we just found for the quadratic, x plus 2 and x minus 3. This is the complete factorization of the cubic polynomial into three linear factors. Let's take a moment to look at the final answer provided in the textbook memo. The memo correctly states that the factorization is x1, x plus 2, x3. It also goes on to find the x-intercepts. Let's pause here. While the factorization is perfect, there's a slight misunderstanding about x-intercepts that we need to clarify. The wording in the memo might be a bit confusing. The question asked us to factorize the polynomial, which means to write it as a product of simpler polynomials. This is exactly what we have done with x.1, x plus 2, x or 3. This is the final answer to the factorization question. Now the memo talks about x-intercepts. This would be the next step if the question had been to solve the equation f(x) equals 0 or find the roots. If the question were to solve the equation x cubed minus 2x squared minus 5x plus 6 equals 0, then we would set each factor to 0. X minus 1 equals 0 gives x equals 1. X plus 2 equals 0 gives x equals negative 2. And x minus 3 equals 0 gives x equals 3. These three values are the solutions or the roots of the equation. The x-intercepts are the points where the graph crosses the x-axis, not just the x values. Therefore, if we were asked for the x-intercepts, the correct answer would be the points 1, 0, 2, 0, and 3, 0. So, while the roots are correctly identified, they are the x-coordinates of the intercepts. The phrasing is slightly imprecise, but to reiterate the core point, for the question factorize, our final answer x1, x plus 2, x3 is complete and correct. Let's quickly recap what we have accomplished in this tutorial. Our objective was to learn how to factorize a cubic polynomial. We've seen a reliable step-by-step method to achieve this. First, we learned how to use the factor theorem. By testing simple integer values, we can find the first root of the polynomial. This root gives us our first linear factor. Second, we mastered polynomial long division. This allowed us to divide our cubic polynomial by the linear factor we found, reducing the problem to a more manageable quadratic expression. Finally, we used our knowledge of quadratic factorization to break down the quadratic quotient into two more linear factors. Combining all three, we get the complete factorization of the cubic. By following these steps, you can successfully factorize any cubic polynomial. Remember, practice is key, so try out more problems. Subscribe for more tutorials from MathZone African Motives. Thank you for watching.